Hello, welcome back. We're going to talk about properties of limits today. And the properties of limits are very simple to work with. So let's go ahead and get started. So we're told for certain properties, we have a function f of x. As x is approaching c, the function is approaching some number L. And we can kind of look at that. So let's say we have f of x here. And what this is saying is f of x is approaching c, but remember from both sides, the value is approaching L. Now, I drew it open. It doesn't have to be open. The value could exist, but what we're really only interested in what we're approaching anyways. And then we're told that g of x is approaching m. So if we take a look at something like g of x here, as x also approaches c, g of x from the right and the left side are both approaching m. And what we want to know is, well, can we combine these two functions and their limits together? And the answer is yes. Even though we talked about in another video that a limit does not always equal a value, we can treat limits like they are values. We saw that when we worked with when we saw problems where we could factor and cancel. Like if I have x approaches 2 of x squared minus 4 over x minus 2, that's going to become the following. The limit as x approaches 2 of x plus 2, x minus 2 over x minus 2. The x minus 2's cancel. And then we said, well, we can just plug that 2 in now and get a 4. So in other words, we're treating the limit like it is a value. And as long as the limit exists, we can treat a limit like a value. Now, there are certain conditions that will make these a little bit harder, but we're going to talk about a lot of those later on this year. So let's take a look at some properties of limits. The first one is called the sum rule. All the sum rule says is, as if x is approaching c, we can add the two limits together, and then we can get, remember, f is approaching L, g is approaching m, we can just add L plus m. Then we have the difference rule, here, which means just subtract them. We can subtract limits. So all these are just the algebraic properties that we learned back in Algebra 1. These are just the same as those properties there. I can add limits. I can subtract limits. We can multiply limits together. We can even divide limits together, provided we're not dividing by 0. And the next one, well, this is a kind of a new one, the constant multiple rule. What that says, if I'm taking my limit and I'm multiplying it by a constant, I can just take that constant multiplied by my value there. I'll give you an example. Let's say the limit, we want to find the limit as x approaches c of 2 times 2 of f of x. Well, that 2 here is a constant. I can just take that 2. F of x was L, so I get 2L. I can just take that constant. Or now, later on, we're going to take it to the outside, but we'll talk about that in a few moments there. We'll show what we're doing there. We can also use a power rule. All that says is if we have a limit to a power, we can just raise our value to that power. The only weird one, the oddball one, is our composite function. You might remember a composite function is something like f of g of x. In this case right here, what we're going to do, for the easy ones, these are easy ones only. We're going to talk about harder ones later. We're going to discuss those later as we get closer to the end of the year. We can just take the limit of the inside function and apply that to get to the value of the outside function. This doesn't always work because it's got to be like perfect. There are conditions that will make this really weird for us. But again, we're going to talk about those ones later on. For now, we're going to keep composite functions very easy for us. You'll thank me later for that one. So let's take a look at some examples here. So here we have a function, f of x as x approaches a is approaching 2. G of x, also as x approaches some value a, is approaching 3. and we want to find if the limit exists. So there are two things we have to discuss right now. One, the answers to these are easy to get. There ain't nobody who's going to have trouble with these. But we are trying to get ready for the AP exam as well. And the AP exam, man, they are a little bit more picky than probably your calculus teacher. So they have certain ways to do it. They want you to rewrite this using the properties. So we are going to use the properties. All right, so for number one, this is my constant multiple rule. Notice I'm taking 5 times g of x. I'm going to write this as 5 times the limit as x approaches a of g of x. I got to write that. Yes, you do. So this becomes 5 times, well, what is g of x approaching? 3. Now, you can leave it as 5 times 3. They don't care about that. They're not worried about you can multiply. But what they want to know is, do you know the properties? So that's why you got to have. That's why you got to have that. So you need this step. Now, of course, you might be like, "Yo, Mr. Warnow, you don't know my family, my upbringing, and everything like that. I got to simplify to survive on the street." You can write that as 15 if you want to. All right, so let's try part 2. Question 2, very simple. We're going to expand it. We're just going to rewrite it. It's going to be kind of a pain. Plus the limit as x approaches a of f of x over the limit as x approaches a of g of x. Now, the first one is real simple. We know f and g, but 6 is just a constant. It's just going to stay constant. It just remains 6. F of x, it's approaching 2, and g of x is approaching 3. So that's going to give us 8/3. There is our answer. Number 3, we're going to look at our power rule right here. So we get f of limit as x approaches a of f of x squared over g of x minus 3. So we would get the limit as x approaches a of, and this becomes, I'm going to square that, f of x squared over the limit as x approaches a of g of x minus the limit as x approaches a of 3. And this is easy. We can do this in our head. This top one just becomes 2 squared, which is 4 over 3 minus 3. So we get 4 over 0, but that really we can't have. 4 over 0, this just does not exist. We're just going to say D and E right there. And there's our answer. All right, next one. Let's have some fun here. Let's look at same things from a graph. The first one, the limit as x approaches -2 of -3 times f of x. So again, we got our power, our constant multiple rule. -3 times the limit as x approaches -2 of f of x. That becomes -3. What is f of x approaching? So let's take a look here. Here's f of x as we approach -3. Here's -3. Oops, sorry, -2, excuse me. From the left and the right, it looks like we're both approaching -1. So that's going to become times -1, which is just 3. Next, expand it. Now notice here, then we're adding and subtracting, and we got a constant multiple, so we got to expand quite a bit here. So -2 times the natural log, at -2, natural log, how silly. -2 times the limit as x approaches 5 of f of x minus the limit as x approaches 5 of g of x. So we get 2 times, what is f of x approaching? Let's take a look here. As we're approaching 5, f of x is approaching 1. Be very careful. The value at 5 is 0, but we want to know what we're approaching, and we're approaching 1 from both sides. Minus, what is g of x approaching? Here is 5. G of x is approaching, looks like 2. So this becomes 2 when we get 0. All right, let me just double check. Oh, that's 2 times 1. Let me just double check. G of x is approaching 2 and 5. We're approaching 1. It looks right. All right, next one. Be very careful. If you notice on this one, we're looking at the left side. We're approaching from the left. Remember, the left side, so it's a single-sided limit. So this is just going to become the limit as x approaches -2 from the left of g of x squared. I'll put the square on the outside there. Rewrite it. and I can see what this is equal to. Remember, we're only interested in the left side for g of x as we approach -2 from the left. This is my left side here. So we're only approaching from the left. And it looks like we're approaching 3. So this is going to become 3 squared, which is 9. All right, I hope you enjoyed this video. Join us for the next video for squeeze theorem. You'll enjoy it.